Hello, everyone. Oh, you all had lunch? I don't hear it. You all had lunch? Yes, that's good. My name is Aparna, and with me I have Anjali. We will be talking about this emerging trend. And yeah, so synthetic data generation. And I would like your 10 to 15 minutes focus because this is going to be a little technical. And this is something which is becoming critical across different industries. So to begin with, I would like to discuss something that we all have common and must have heard. How many of you know about the Mark Zuckerberg and its trial related to data privacy? Oh, you know that? Great. And do you know which year it happened? Yeah, it was started in 2018. And from there, companies started to change their perspective against the data. So data just not became a useful thing, it started to become critical. And along with that, whosoever is working, like if you are in some company, like I see people from NetApp and other companies, you went through the compliance training, I hope, right? So in the compliance training, we understood that how much privacy is important for us. So this brings us on the first part, that is a data paradox, where we face the issue of needs versus privacy. To begin with, any model to train, what you need is good data set. Or even to create a framework, you need to have a data set with different variety. Better data set means better performance. And I would like to give an example for that. So this was our use case in our company, where we wanted to detect the personal identifiers. You can see here two identifiers. One is the phone number, and the second is the name. But ML, to understand it, what it needs is that question could be, how many digits should it have? Or if it is a name, then how would you distinguish it, right? How would you distinguish from the string list that you have? And what we wanted in the end result, that we want to redact them because we cannot use the personal information. So when we started building our model, or when we started to validate it, for us, the hardest part was not the model accuracy. Instead, for us, the hardest part became the data set itself. And why? Because we needed to have the compliant and usable training data. So this is one of the use case, but let's dive deeper into it. And for that, I would like Anjali to give you the details about the requirements.
Thanks, Aparna. So before jumping into this slide, I want to ask a question to everyone. So have you ever raised any sensitive data request in your organization, ever in your career? Or do you know about these terminologies like these GDPR, HIPAA? Have you heard about these? Yeah. So these are basically the compliance. Compliance are the rules and policies on top of data. Data may contain some sensitive information or personal identifiable information, so we need to protect that, right? So GDPR is basically for personal identifiable information protection. HIPAA is for some medical information protection, right? So and we have many more protection as well in the data. So because of these constraints, we cannot directly use this data for our model training or any other analytics purposes, right? So this is one of the limitations we have in data, real data. Second part is data scarcity. So I'll give an example for that. Let's say we are working on an automobile industry, and I want to build an automatic car. So what happens is the data we have currently, like environmental factors, accidental data, or any other condition of data, is not enough to test the model. We want to make our model more efficient. We want to make our model well-trained, less error-prone, right? So we don't have enough data on those scenarios. This is one of the limitation I can say for real data. Another is the biasing part. So what happens is, if I want to build a generic model, right? So what happens is I don't have, like, the data is very biased based on gender, based on age, based on racism, right? So for any generic model, we cannot use that data because it will make our model biased, right? So this is also one of the limitation. Also, we have like this regional identifiers. So what happens is, let's say my data resides in India, right? And I train my model with Indian data. So if I'm trying to find out the national identities like Aadhaar or any PAN, it will be able to identify it because it have like those 12 number digit or any identification for that, the pattern for that. But if we are moving it for any other reason, like US, we have SSN number, which has 9 digits, right? So it will start failing for that, or it will not recognize that pattern. So this is also one of the limitation we have in real data. So I hope you have some clarity of like what are few limitations we have in real data. And to overcome these limitation, we have to generate the synthetic data. So now what is synthetic data? So synthetic data is basically the data artificially generated using some algorithms, patterns, some domains according to our use case, but that data will not contain any sensitive information or any personal identifiable information. That data will be similar to the real data, but it will not contain any real event information, right? Okay, maybe I can repeat this slide for you. so what is synthetic data? We know that real data have some problems. So synthetic data is basically the data artificially generated because using some algorithms, some patterns, some domain-specific knowledge, and that data will not contain any personal identifiable information or any real event information. Also, that data will be somewhat similar to the real data, right? So with this, I have a new like small animation, fun animation for you all. This is a model, and it's saying I want training data, right? And then because of some compliance or maybe some limitation, we cannot directly share the real data to that machine. So machine is saying, okay, fine, I'll do it myself. Give me patterns. Give me something to recognize. Give me something, some use cases for it. So now we have all the things, like model can generate the data, but the problem, not problem, but the question comes in mind is, okay, we generate the data, but why we cannot use the already existing online data, right? We have like lot of platforms, online sites, why we cannot directly use it? So for that, so the real data is having lot of, the online platform data is having some shortcomings, right? So what happens is, the data is scattered in different places, first of all. So we cannot directly go and use it. We have to do a lot of processing on top of that. We have to do a lot of cleaning on top of that. Also, the data is not consistent. The data is inconsistent. Maybe they can have like future dates, right? Maybe they can have invalid timestamps, right? Any inconsistencies can be there in the data. Also, if I'm going with organization-specific data, right? I want to train something on my organization. So I need my organization-specific data, like organization ID, like any other patterns which followed my organization. So now we know that open source cannot like completely take all the things, right? It will not give us what we want. So for, at least with this slide, you know some idea of like what is the problem statement, what is synthetic data, why we want to generate it. So we have some clarity on that at least. So now I want Aparna to take this forward for the solution part of it. Thank you.
Thanks, Anjali. So with this, we understood few things. First, what is the synthetic data and why we cannot use the open source synthetic data that we have. So what do we do now next? So we built it. How we did that? Let's take an example that we discussed in the start of the session, right? Where we had the contact number, as well as we wanted a name to be extracted. So what I wanted to do, I wanted to create a user data table, and that should be a synthetically generated. For that, what we're going to do is that we will provide all the information, necessary metadata, into the context generator. So let's assume you have a user data where you wanted its username, country which is belong, zip code, or company-specific SID. So all these information, you gave it to the context generator. Additionally, sometimes what happens is that I, as a user, want that mostly my data is from the US. So let's have 60% of the data in the US, 30% of data in India. You provide that also inside the context generator. Along with that, you have the noise margin, which you see on the top. What this noise margin does is that it gives that real data thing to the synthetic data. It tells that, OK, because in the real data, when you submit the things, it is not always as clear or as good that we want. Okay, so all these things goes inside the generator. So generator consists of the two layers. The first one is the pattern-based, where you use the algorithms that are available, scripts that we have created, regex-based scripts, and finally the faker, which is one of the Python module. So we combined all these together to create the pattern-based generation part. So in that, what happened? That simple things like name, contact, all these things will be created. But what is the icing is the LLM-based thing that we are introducing. What we are doing here, we are giving the good prompts inside it, and that good prompts gives you a better data. And where exactly we are getting the information on those good prompts? That is coming from this main thing, that is real data domain knowledge. To give you an example, like see, in my company, we have prefixes for each of different domains. For example, for user, we have AL. For organization, it's SD. For customer, it's CD. You provided all these information to the generator. Once the generator has this information, it creates on the basis of that. And later, we have the discriminator layer. This discriminator layer kind of compare what is generated as well as what is created from the knowledge domain. In the comparison, if it finds that, OK, it is more than the threshold that we expected, it gives the feedback back to the generator. In between, there is one more layer which is very important. That is the validation layer. So validation layer, what it does is that, let's take an example, I would say. Here, you see name Mary, and zip code it generated. But if you see the SID, it has a prefix with SSS. OK, so our expectation was to have the prefix with AL as per the company's policy. So what it does is that it rejects it. And then that goes as a feedback. And finally, what you are left with is the core synthetic data, which has whatever our expected values from the real data domain. So with that, we were able to create the synthetic data. Now let's understand how it helped us or how it unblocked us. So I have divided into the 4 categories. The first one is the accelerated training. So now we are no more dependent on approvals and access policies that we were used to, and it would take like sometimes weeks to get the approval. Now that is gone because it's our own data that we have created. Second comes the security and privacy, because since it's a synthetically created, so no more privacy issue, right? So it's easy to get the approval. Last one is the scalability. So far, the real data is whatever is present, you have to use it. But now with this, we can have the multiple tables, different domain, different regions, whatever masala you want to add, you can easily add in this layer. And the last one is the reduced bias. I think that's Anjali already covered. With this, we solved our problem. But one question comes to our mind, that is just the Twilio who developed it? No. Answer to that is that there are many different companies, and they are doing the innovations in this sector. So for that, I would like to highlight here, for example, Roche Healthcare. What they are doing, they are creating the synthetic data so that they can fix the diseases, or they can figure out the reasoning of those cancers and other diseases that are there. Apart from that, there is Google Cloud Plus and the Gretel. They are working in the privacy domain so that they have the GDPR compliant data that is eventually fetched into the BigQuery. Now, this is the final slide, and I would like to conclude that being a data engineer in the company, we have realized that this is not a luxury thing. If you want your project to execute and make a progress, this synthetic data generation is becoming a backbone, and it is the future. So with that, we conclude our presentation. And lastly, I would like to thank Sandhya, Kalpana, and others organizers who helped us to reach so far. Thank you. Thank you, everyone.